There are a few properties of signals generally. When you receive a signal, when a process receives a signal, there's no extra data that goes with that. When you send a signal, you just give it a signal number. You can't supply an integer even or a string or anything to give data with the signal. All you get is a signal number. That's why when we get a child signal, then we have to explicitly call wait to get more information about what happened to some child, even which child it was. There's some time between when a signal is sent by the sending process and when it's delivered, that is when the handler for the signal is called in the receiving process. In the in-between time, we say that the signal is pending. And we'll see reasons why a signal may stay pending for a while, but while a signal is pending, if you send the same signal to the process again, nothing happens. There's no queue. So the state of a process is that for each signal, either it's pending or it's not. There's no way to count how many signals have been sent and so on. Now, as we said, a signal can be pending for some time, and that's because a signal can be blocked. That's under the process's control and can request blocking signals. Well, not sigkill, for example, but most signals it can request to be blocked. And what that means is any signal sent to the process will stay pending until the signal is later unblocked. And finally, of course, each signal has a handler for delivery. So that's all the information that the kernel needs about signals for a given process. It'll keep a table for each process, something like this, for each signal, whether it's currently pending, whether it's currently blocked, and what is the handle for that signal. If a process was in this particular state, you see there are two pending signals, sigint and sigil. Sigint is blocked, so that can't be delivered, but sigil is not blocked. And so at some unspecified time, when the process becomes into the state, but probably quickly, then the normal control flow of the program will be interrupted and the give up handler will be called. While the give up handler is called, the signal is no longer pending. But another thing that happens by default is that while this handler is called, the sigil signal will be blocked. That way, when you're trying to handle sigil, you don't have to worry about another sigil coming in the middle and interrupting what you're doing to try to handle the first sigil. Meanwhile, some other signals are not blocked, so it could happen that while you're handling sigil, a sig-hup comes in. And then you just have to arrange that your sig-hup handler, if you have one, works okay with your sigil handler when it runs in the middle of the sigil handler. Or you block sig-hup explicitly when you handle sigil.